In this video, I attempted to get my dog Charlie to cooperate and be the perfect dog being taken for a walk, so I could illustrate a concept for you. Well, he's not the most obedient dog, so he really didn't cooperate fully, but hopefully I can pause and deconstruct parts that did work. So in this first shot, Charlie is taking me for a walk. There is a force of tension in the leash as I'm trying to pull him back. The angle between the leash and the horizontal, which is Charlie, is 55 degrees. So I have a question for you. So if this caused you to ponder and you answered C to the question, that's good lateral thinking. The thing is, to Charlie, the influence of the single leash on his body is equivalent to the influence of two leashes on his body. One pulling upwards and the other pulling to the right. If the single leash were replaced by two leashes, one up and one to the right, then Charlie would not know the difference. Charlie would not know the difference, not because Charlie's not smart, but rather because the tension is a resultant vector of two other vectors, the upward vector and the rightward vector. These are known as components. The combined influence of the two components is equivalent to the influence of the single, two-dimensional resultant vector. Now, what expression could you use to calculate the upwards component of the tension in the leash? And what expression could you use to calculate the rightward component of the tension in the leash? Hint: construct a parallelogram. Look at this picture. Now I am really taking Charlie for a walk. The angle between the leash and the horizontal is 42 degrees and the tension in the leash is 12 newtons. Calculate the horizontal and vertical components of the tension in the leash.